Welcome to Part 3 of Chiron GMAT's Introduction to Data Sufficiency. Last time we learned a 4-stage method for solving data sufficiency problems. Here in Part 3 we'll deepen our understanding of this method by using it to solve 2 more problems. The examples have a slight twist that will make us adjust how we use the DABC grid. Let's get to our first example. In this problem, the top section reads, at company C, what is the ratio of the number of female employees to the number of male employees? In the initial stages of our solution, we'll focus on this top section. However, it's a good idea to look ahead and skim the statements, so that we have a sense of what's coming. Statement 1 says, if the number of female employees at company C were 12% smaller, the number of female employees would be 80% of the number of male employees at company C. Remember, right now we are just skimming, so it's okay if you didn't absorb all of that. As for statement 2, it tells us that company C employs 650 females and 715 males. Stage 1 of our solution is to process any givens. In this problem, however, there isn't really any given information in the top section, so let's move on to stage 2, which is to process the question. The question is this part, which asks for the ratio of female employees to male employees. On our scratch paper we write Q for question, then female over male equals question mark. We don't need to specify that this female to male ratio is for company C employees, because when we skimmed the statements we saw that everybody in this problem is employed by company C. Now that we are done with the top section of this problem, it's time for stage 3, which is simply to write the DABC grid. And finally, stage 4 is to process these statements. Statement 1 is kind of a mess. It starts with an if clause, it gives a couple of different percents, and it's long. On the other hand, statement 2 looks simple. It straight out tells us how many female and male employees there are. We might as well start with this easier statement, especially since under the time pressure of the exam, we might not be able to process both statements. So let's write 2 female equals 650 and male equals 715. Is this sufficient to answer the question? Yes, because we now know that the ratio female over male is 650 over 715. Thus, statement 2 is sufficient. Based on this result, which answer choices can we eliminate? Let's expand our DABC grid to check. Remember that in these labels the word hero designates a sufficient statement. D might be right. Double heroes means each statement is sufficient, so D recognizes that 2 is sufficient. B is possible because it also recognizes that 2 is a hero. On the other hand, A is wrong, because when it says 1 is the lone hero, it contradicts the fact that 2 is a hero. A and B are opposites, so one of them always gets eliminated in the first round. As for C and E, they claim that neither 1 nor 2 is sufficient. Since 2 actually is sufficient, C and E are wrong. Anytime we start with statement 2 and find it to be sufficient, we get to cross out A, C, and E in one swoop. Let's move on to statement 1. It starts with this clause. If the number of female employees at company C were 12% smaller. This is describing a hypothetical situation, so we will need to keep track of both an actual scenario and a hypothetical one. In both of these scenarios, there are still the categories female and male. To keep track of all this, it will be helpful to draw a table. Let's say that in the actual case the number of females is X. We're told that in the hypothetical case the number of female employees is 12% smaller than this. What's 12% smaller than X? Well, 100% minus 12% is 88% of X, or 0.88X. What about the males? This blue clause doesn't mention a change in the number of males. So if we say that in the actual scenario there are Y males, then in the hypothetical one the number of males is still Y. Now that we're done with this first clause, let's turn our attention to the rest of the statement. It tells us what would be true in the hypothetical case. The verb to be expresses equivalence, so this second clause can be translated into an equation with the words would be represented by the equals sign. To the left of would be in the clause is the number of female employees. Since this is about what would be, it refers to the number of females in the hypothetical case, which we can write as hypo-fem. To the right of would be in the clause is 80% of the number of male employees. This we can write as 0.8 times male. To be more precise, we could write 0.8 times hypo-male, because this whole clause is about the hypothetical case. I just wrote male because the number of males is the same in the actual and hypothetical cases. We have now finished translating the statements, but we still have work to do on our equation. From our table, we know that hypo-fem is 0.88x, and since male is y, the right side of our equation is 0.8 times y. To help us figure out whether this information is sufficient, let's rewrite the question in terms of x and y. The question asks for the ratio female over male. It doesn't mention a hypothetical case, so it must be talking about values in the actual row of our table. There, female is x and male is y, so let's write Q x over y for female over male equals question mark. To see what our equation can tell us about x over y, we divide both sides by y. On the left side, this yields 0.88x over y, and on the right, dividing by y leaves us with 0.8. Things are looking pretty good. This latest version of our equation can clearly be solved for x over y, so we should mark statement 1 as sufficient. Of course, you can keep going here to get more explicit about x over y. Dividing both sides by 0.88 turns the left side into x over y, and the right into 0.8 over 0.88. This last line is optional, so I'll make it fade to gray. What you definitely should not do is spend any time calculating the value of 0.8 over 0.88. With the time pressure on the GMAT, you should stop solving as soon as you can tell whether a statement is sufficient. Alright, let's enlarge the DABC grid to pick our final answer. Each of the statements is sufficient, so this is a case of double heroes. The answer is D. One last thing to notice about this problem. Because we started with statement 2 rather than statement 1, the first choice we had to make on the DABC grid looked like this: DB versus ACE. In all of our previous examples, we started with statement 1. And when you start with 1, the first decision on what to cancel looks like this: DA versus BCE. So A and B end up on different sides of the dividing line, depending on whether you begin with statement 1 or statement 2. To understand why this happens, let's take a closer look at the DABC grid. The reason for these shifting alliances is that A and B disagree on which statement is the lone hero. The reason for these shifting alliances is that A and B disagree on which statement is the lone hero. A says 1 is the lone hero, so when we focus on statement 1, A sides with D. This means that if we're solving a problem and we decide to start with statement 1, the first choice we face will be DA versus BCE. If 1 is a hero, we cancel BCE. On the other hand, if 1 is not a hero, we cancel DA. So that's what happens when we start with 1. If we focus on statement 2 rather than 1, these alliances are reversed. The reason for this change is that B, which says 2 is a hero, is the option that agrees with D about statement 2. So if we're working on a problem and we decide to start with 2, the first choice we face will be DB versus ACE. If 2 is a hero, we cancel ACE. On the other hand, if 2 is not a hero, we cancel DB. Alright, let's put that aside and consider our very last example. This one reads, if A, B, and C are non-zero integers, is AB over C squared positive? Statement 1 is an equation involving AB, and statement 2 tells us that B is positive. As always, stage 1 of our solution is to process the givens. Here the given information is that A, B, and C are non-zero integers. So, next to G for givens, let's write A, B, C integers not equal to 0. Stage 2 of our solution is to process the question. Here the question asks, is AB over C squared positive? So let's write Q AB over C squared. To ask whether this fraction is positive, we can write equals pos question mark. What can we do to simplify this question? Well, it asks about positive versus negative, so we should notice the term C squared. The sign of C squared has to be positive, because any non-zero number squared is positive. For example, 3 squared equals 9, and negative 3 squared also equals positive 9. Now, given that C squared is positive, the sign of the whole fraction AB over C squared will just be the sign of AB. That's because dividing a quantity, in this case AB, by a positive number does not result in a change of sign. Since the term C squared makes no difference to the sign of the fraction, we might as well get rid of it. So let's just ask whether AB is positive. By the way, the rule that told us C squared is positive is part of a bigger rule that is worth jotting down. The larger rule says, for n not equal to 0, that means for any number n that isn't 0, n raised to an even exponent such as 2 is positive. Now that we are done with the givens and the question, it's time for stage 3, the Dabsey grid, and stage 4, the statements. Statement 1 looks somewhat complicated. Not horrible, but it does have 3 variables and 2 exponents. In contrast, statement 2, which just says B is positive, looks pretty simple. So we might as well start with statement 2. Let's write 2, B equals positive. In this equation, the abbreviation pos stands for some positive number whose value we don't know. Since our question asks whether AB is positive, we should work on statement 2 to make it tell us about AB. To do this, we can take our equation and multiply both sides by A. On the left side we get AB, and on the right side we get A times positive. Here on the right we have A times our mystery positive number. This boxed quantity must have the same sign as A, because multiplying A by a positive number does not change the sign. Of course, anything that is true of the boxed quantity is also true of AB, since AB equals the boxed quantity. Therefore, AB also has the same sign as A. This may be interesting, but we don't know the sign of A, so in the end statement 2 doesn't tell us what we want to know, whether AB is positive. Therefore, statement 2 is insufficient. Let's enlarge our DABC grid to see which answers we can now eliminate. Recall that when we start with statement 2, the choice we face is DB versus ACE. In this example, we have found that statement 2 is insufficient, or not a hero. D and B say, falsely, that 2 is a hero, so we must cross them out. Now let's tackle statement 1. This is an equation that we should copy onto our paper. The left side of the equation is just AB. That's convenient because the question is about the sign of AB. Let's examine the right side of the equation, c cubed b squared, for any indications about positive or negative. This term b squared must be positive because, as we've seen, any non-zero number raised to an even exponent is positive. The complete right side is thus c cubed times a positive number. Multiplying c cubed by a positive number does not change the sign, so the expression in the gray box has the same sign as c cubed. Of course, the two sides of the equation are equal, so AB also has the same sign as c cubed. But what do we know about the sign of c cubed? Our green rule about exponents has a corollary that can help us. This states that n raised to an odd exponent, such as 3, has the same sign as n. Thus c cubed has the same sign as c. Applying this to statement 1, we can say that AB has the same sign as c cubed and c. Unfortunately, we don't know the sign of c, so we still can't say whether AB is positive. Thus, statement 1 is insufficient. How does this result affect the DABC grid? Let's have a look. Answer choice A says that 1 is the lone hero, but we have just seen that 1 is insufficient, so A must be wrong. On the other hand, C and E say that each of the two statements is insufficient, so C and E remain possible. To choose between C and E, we'll need to see whether statements 1 and 2 together are sufficient to answer the question. Until we do that, we can only eliminate A. Alright, let's wrap this up by combining statements 1 and 2 into U, the united statement. From statement 2 we learned this: AB has the same sign as A. From statement 1 we learned that AB has the same sign as C. So the united statement must say that AB has the same sign as both A and C. But what do we know about these guys A and C? The givens only tell us that they are non-zero integers. So it's possible that they are positive, which would mean that AB is positive. But it's also possible that they are negative, which would mean that AB is negative. So to the question, is AB positive, we can only answer, maybe. Thus, statement U is insufficient. Let's use the DABC grid to choose the final answer. We have found that even together, statements 1 and 2 are insufficient. They are, in other words, hopeless. So the answer is E. Picking E can feel unsatisfying. We seem to have given up and accepted defeat. But that's not a good way to think about it. The true goal in data sufficiency is to reach a verdict on the statements, and that's exactly what we did here. On the GMAT, E is correct as often as any other answer choice, so you really shouldn't hesitate to pick E. One last point. When you start a problem, it's a good idea to ask yourself, what is this about? What rule or formula is relevant? If you can think of a rule that seems relevant, you might as well jot it down. It's likely to be useful. In this problem, for example, we got a big boost from using the green rule about odd and even exponents. And now, it's time to congratulate you for reaching the end of another video from Chiron GMAT. Next time we'll wrap up our introduction to data sufficiency with part 4, a quick review to help crystallize what you've learned. Do join us for that.